Well, the gimbal keeps turning off. I know it's crooked, but it won't stay on, so we're going to have to deal with it. This is a floor plan for a house, the first house we designed for the Philippines. As you know, it's an earthquake-prone place, and we called this one Aurora's Castle. It's a two-story. The bottom and top walls are right over top each other. The difference is this center wall right here isn't on the upper level. The rest of it's pretty much the same. It's like a bed and breakfast kind of deal. We have 1, 2, 3, 4, 5 small, well, they're not small. They're pretty big. And the master bedroom and master bath. All these other bedrooms, you have to go through another door or something to get to a bath or CR. Damn this gimbal. It's got a mind of its own. It's better than we had it the first time, I think. Okay. Also, if you have like a family of people with small children and they want to stay here, this master bathroom here, master bedroom, master bath, a small bedroom is like a enclosed suite. You'll see some blue boxes and red boxes around different places. Those are bucks, the placeholders for windows and doors. Let's make a little change here on the scene. I was going to make a short video, but I'm going to fight this gimbal the whole damn way. Well, that's putting perspective in perspective. As you can see, all those little red blocks and blue blocks, like red was windows and blue was doors or whatever. So this is the floor plan over here. There's a whole lot of windows and doors. The main entrance is here, and there's another entrance back here. It's like a fire exit entrance. And somewhere down at the end of that's the one at the end of the kitchen. Where's the other one? There's 3. Well, it doesn't make any difference. There's 3. And the camera's going to be upside down in a few minutes. Let's get back to... Well, we can do it. Let's go back screen. It's probably easier. Damn. I'm just going to hold this and let the motor burn up because I'm not going to fight the damn thing. This is called buttress construction. Just... It is just not going to stay in place. The camera's balanced. I've set the thing up. It's never worked right. Okay. This is called buttress construction. It goes back to days of Renaissance architecture and before. Basically, when this wall braces that wall from leaning up or down, and it braces this wall from going up and down. Same thing with all these corners. This braces this section together. This braces that. Down here, the interior wall is the brace. It's not an exterior brace this time, it's interior. And that goes around the whole building. Also, this house is drawn up to be hollow block construction, except that we were buying the block machine from China for $3,200. It makes like 12 blocks at a time, and you can make them as much cement content as you want. Now this thing has a block what we were going to cast on site. We can just order the molds from the block people. Let's go over here beside this little. This video would be much shorter if I could just get some cooperation. These are the kind of reasons my videos are not watched. I just have to fight with the equipment. It gets me so depressed, I don't want to even mess with it. Okay. You got this piece up here. I don't know if they're... Yeah. You can see the shape of the outside of it. And then this one would be that shape. And of course, they're hollow. That's to run wiring and drain pipes and stuff through. And these are made where you can lay them left and right, you know, so that you have a brick lap on the courses. These are 8-inch blocks. We were still thinking sort of a U.S. kind of manufacturer. You know, like we built hollow blocks over there, but we have actual concrete blocks. This is the other specialty block. And this is showing a mortar joint on the end of it so that, so that it makes an actual, you know, concrete block wall. There's another thing about this. Where did I write it all? Okay. What this drawn here is precast concrete. It's done up there at our side of Manila. There's at least 2 plants, and basically it's a couple pieces of wire rope cable in a 3 by 10 inch rectangle, and the wire rope cable is the tension of it. They make it in bigger sections for bridges, like 2-lane and 4-lane highway bridges, but they're not very expensive, and so you can use a lot of them. Now, what this is showing here is blue ducts or air conditioning into the house. Red ducts are returned to the heat pump, which is located on the roof above the master bedroom closet. That would be over here someplace. So the blue ducts are air conditioning in, and it says red ducts. That's not making any sense at all. What there's blue and green. One is air coming in, and the other is air going out. And they run into joist spaces. See, below this you'd have your tray ceilings closing it off. Let's see something. Anything else that's more. Down here in the bottom, this is the circles are the grills into the ducts. You know, that's where they are placed in the house. Let's see what we got up here. Oh, okay. My buddy here's trying to turn himself over again. Don't ever buy a gimbal. They're good for walking around, but they're not good when you want to stay still. They don't work with a crap. And this is not a cheap one either. It's rated for my phone, and the phone doesn't really fit in it. It's well within the weight limit, but where it clamps on the phone is just barely makes it. And I had to turn rubber inserts inside out to make it even do that. Okay, what we're looking at here, oh, that's too big, is the footers. This is the bar of concrete that goes around, and you have walls sitting on the middle of all of these. And these are sized according to U.S. codes. But normally I pour footers in the floor monolithically, one solid piece. But in this case, we were going to pour the footers pretty much a room or two at a time, and then we're going to pour the rooms like two at a time or whatever, because I didn't know you could get ready mixed concrete. Myself swore they didn't have it here, and I didn't have any confidence I could buy sand that wasn't out of either the ocean or rivers that was full of salt. That makes crappy concrete. So I was worried about the sand. I didn't want to get involved in having to pour a slab. We'd use it for something, but I had to pour some kind of a slab for this egg crate machine. It lays the blocks like a chicken laying eggs, and then it advances. To put the next 12 blocks down. And I thought we would spend our whole first year here getting tooled up to make concrete blocks. Then I wasn't too sure about the materials quality. The house has an awful lot of corners in it. It's really if you take the time to look at the way the rooms are connected, it's a pretty good floor plan. Not sure that this is going to show us anything we haven't looked at. This is just the blocks with no footers, and it gives you all the sizes of the rooms. This particular drawing is in inches. 184. Golly. Well, 12 is 144. It's 12 feet. It's 16 feet by 10'8". That's the master bathroom. And by anybody's standard, a 16-foot long, 12'8" bathroom is a fair size. And the bedroom, of course, is bigger. We have a 216-inch long kitchen. 240 would be 20 feet. So it's 18 feet 9 or some mess like that. And the width is that same 184 inches that was on the other thing there. Obviously, we would have a dinner table and some chairs here in the kitchen. And if you have some kind of a fiesta and stuff, have people in. It's got a flat concrete roof, so it's living space on the roof. Barbecue grill and all that stuff goes on the roof. But she's got a thing here labeled classroom. Of course, it'll probably show in what you're looking at. I've got something drawn over it on my camera here. It's just being a mess. She likes to teach accounting. She's an accounting professor, and math. She thought she could make a little bit of a living over here teaching high school math or calculus or whatever. The kitchen's got its own actual pantry, and it's in one of these highly braced areas. If you have an earthquake, one of these 4 rooms like this is probably where you want to head to if you don't want to go outside. Like if it's pouring down rain, which occurs a lot in the Philippines. And this floor plan doesn't have, except for the master bedroom, it doesn't have in-suite bathrooms. Not that it couldn't. You can put doors in any wall. Also, being that this drawing is to scale, let's take a look here. That's showing the blocks with the mortar joints. And obviously you've got a 5.5-inch square concrete post in every oh golly, it's 4 of them in 32 inches. That averages about 8 inches, I guess, on center. So that makes a pretty stiff building with these hollows are big enough to actually be concrete, not mortar. It would have the rock in it, just like the cement in the foundation. This pipe going across here, that's some kind of a septic tank or a gray water tank. Those are all drawn out on the drawings too. But that doesn't make a whole lot of difference for what we're trying to do. I was having trouble focusing on that. Each of the lesson there. This is the walls sitting on footers. And this would be like looking at the walls without windows and doors yet. Basically, I draw the this is it drawn up in poured concrete, which is what we were going to go to. It seemed like it would take less time to build, especially with slip forms. In the poured concrete version, you don't need any sonotubes full of cement or anything like that to hold the roof up. Oh, you need something to hold your camera level. These actually, all the walls are drawn in 3D, and then the window and door placements were put on them. Oh, let's go here back to this other thing a minute. Yeah, and we ended up back on the screen. Okay, being this is the first floor, it has small windows, and the idea there is they're high enough up to keep passers-by from just looking right into your house. We're not Dutch. We don't want the outside to look in and make us feel like we're not being hospitable if they can't see in the house. They don't even put curtains on the windows over there. It's considered to be rude. Big bathtub out in the middle of the floor of a room, and everybody's sitting taking a bath, and then walk down the street and wave at you. I don't understand it. Anyway, the security grills on the windows go on the inside. They're hinged on the bottom, and that way they got a handle at the top that locks them. If you have to get out a window in case there's a fire, like somebody lights a bed on fire and fills the whole house full of smoke, some of that rubber in mattresses is really toxic. Anyway, you pull the handle. This grill drops down. The bars are horizontal. That makes it into a ladder to climb up and bail out. You have to get the 5 feet to the ground. That might be a problem for children, but oh no, not for children. It'd be a problem for adults. I'm not sure why some of these doors have a square top. I can't remember, but there is a reason to have a second shape on the door. It will take different bucks. Anyway, second floor, camera. Second floor, the windows are much bigger. The workshop is up there, and a sewing room, and 3 or 4 other specialty rooms, plus another half dozen bedrooms. And the staircase is in this, what room is it in? It goes along a wall. I'm not exactly sure where right now. We haven't looked at this for about 6 years. Because we're building the other house, the one called Decagon House. Of course, nobody knows anything about it because nobody looks at our channel. But the Decagon House is simpler to build. It hasn't got hardly any corners in it. Of course, the corners are 72 and 108 degrees. You know, one depends what side of the wall you're on. Where this has 90-degree corners. This can be built out of hollow blocks because those specialty corner pieces were the columns. And also, if you use an 8-inch hollow block, Jack built blocks in the Philippines makes them. You got a 5x5 concrete column about every 8 inches. It's really a house full of columns with some hollow block surrounding it. And we were going to lay the blocks really neat, sort of U.S. style, and just tool the joints. We weren't going to render them or skim coat them or any of that. Anyway, we didn't build this house. We built the Decagon house. This house was bigger than the Decagon house, a lot bigger. If you, We might have overall dimensions here somewhere. Oh, okay, this is the sanitary lines. Sanitary sewage lines. Green lines are gray water collection. So that's a 3.5 inch. And there should be another color of, be another drawing. The black water is in separate pipes. The gray water, that's showers, sinks, laundry equipment, all that kind of stuff. And obviously, this drawing doesn't have the black water pipes in it, and it's all drifted off the screen again. You got the love of gimbal. Oh God, yes, let's really fight. He thinks it's stronger than I am. Surprise! What we were looking for here. If you divide 630 by 12, that's the dimension in that direction, which is from the ziggly wall up here to the wall back here. This is an entry hall, and it's not on the screen. Yes, it is. Yes, it is. It's just not big. So that is a door in and out of the house. And the roof overhangs is 4 feet all around the whole building. It keeps the sunlight off of the walls. And this really huge door is a double door, French door. That's the main door to the house. It's the biggest door. Come on, gimbal, give up. It's going to kick off in a minute when the motor starts to smoke. I turn the whole blasted platform around, I might get someplace. Anyway, the purpose for making this video is just to show a floor plan. I was watching Texas Filipino, and he was kicking around his original plan for his house that he's building. Completely different than the one he's building. It's equally different from the actual build as this is from the Decagon house. There's also views on this drawing from other directions. This is showing some the boxes that were on that other drawing, the red for doors, blue for windows. Stay. So basically, the poured concrete walls were just the shape of the imprint on the floor, extruded up 10 feet 2 inches. And then these are just placed in there, and you subtract the cutouts from the solid wall. And that's how you get these other drawings with the windows and doors knocked out of them. For instance, this is the drawing with no windows and doors, just walls. Over here, the black line that won't focus because there's so many lines close together and the camera's confused. Not the gimbal this time. Anyway, the black lines are inside of these footer shapes. Those were extruded to make the blue lines over here that are the full height walls, and then the boxes are put in. And you delete out the boxes out of the shape that was there, and you end up with walls with holes in them. This is what the boxes would look like with no building there. Actually, this is the boxes when we were still had the option of doing it with concrete blocks instead of poured concrete. And being the blocks with the 1/2 inch mortar joint, the blocks are 16 inches long by 8 inches wide. If you have a picture of the blocks, you basically can determine the size of any of the rooms. Now, the Decagon house, we went out and laid out all the rooms with, I think it was Coat Saver white paint on the grass in the rice field, and walked around in the rooms. The idea, architects will tell you to do it too. You walk around in it and see if the doors all swing the way you want them to swing. Like when you open a door, do you have to walk around it to get into the room, or it doesn't fold against the wall, or there's no place for it to go? The space isn't big enough for the door. There's a whole lot of problems with doors. And then windows. You look in a place where you have windows marked and see if it looks like you could put furniture in the room. I mean, you can't just build every piece of furniture in your house. You could, but you'd never get it done. But anyway, you walk around in it, and while you're checking door swings and a few other things, you say, is this what I envisioned this room to look like? Is this the size that we really want for the master bedroom? And if it's anywhere close, yeah, it's a good size. If it looks too small and several more rooms look too small, you go back to CAD and you scale it in 3D. It's transform slash scale slash 3D. You select whatever you want to scale, select an origin point, and then like you can make it 1.05. So I'll make it 5% bigger. When we laid out the Decagon house, we thought the rooms were small. So we added 5% to the entire floor plan. And then we did the drawings and went to the building permit people. But we upscaled the whole house. I did that on my my other build, which is it's 2 brick walls. It's 10 whole bricks. 10 they have holes in the bricks, just like hollow blocks have core holes. The bricks have core holes. That lets the mortar get up in them. 3-hole brick versus 10-hole brick. There's more concrete to shear off. More mortar got to shear for the wall to crack. So I use 10-hole bricks, and they're solid color. There's no sand thrown on a hot brick and hope it'll stick. The dirt of the brick is the same color clear through. So I'm using never mind what colors. Anyway, I got these 2 brick walls inside and outside. Every wall in the house. There's about 600 feet of wall in that house per floor. And I took some 1/4-inch hot rolled round rod, run them through my iron worker and sheared them off against a stop. Made about 6,000 of these little short, 20-inch long pieces of quarter rod. And then I had a tool with ball bearings on both ends and a handle. And you push the rod against a stop, pull the handle one way. Then you run the other handle, and it bends the second end. Makes them all the same size. We bend 1.5 inches down, and the rest of it goes between the outside holes of the bricks. So that drops into the mortar holes when you're laying the things up, and that keeps the wall from blowing up when you pour the concrete in it with a pump. So we pumped the house. It took 5 hours to pump the walls in that house. We went around 3 times. The first pour was like 3 feet 6, and then we did about 3 feet. And then the last pour, I'm not exactly sure how much that actually was, because we were just covering up some of those rods that tie the brickwork together. We were just going up to till we buried a certain rod. And see, you're going around and around over all these walls with a pump, so you can see where you are on the height of those round connecting rods. So we were shooting for 3.5, 3, and then the rest. And of course, by the time you get the second time around, that first layer of concrete is 3 hours old. I mean, the newest of it is 3 hours old. So you can pour anything you want on it. It won't ever blow out then. And the top doesn't ever seem to give any trouble. I don't know why. It seems like it'd be just as susceptible. But the bottom has a lot more hydraulic pressure if you just poured it bottom to the top. Now, the Decagon house, we poured the wall, which is 8 feet. And then there's an 1.1 inches That's a spacer on the forms. And then the beam forms is above that. That's 2 feet. And there went the camera. So we poured 10 feet, 1 5/32 of an inch. And right from the bottom to the top. We just poured it in any place we happened to be. We put the 1 bag mixer right next to where we were going to pour. We had 4 foot wide, 32-inch wide scaffold all the way around everything, both sides. And the 2x3 good wood, like Nara wood, that made the supports for the scaffold, also squared the wall, made sure it was plumb. So you didn't have to do any of that. It was automatic. But being that we were actually using real forms, and those are on our vlog someplace. Everything we do is, if you need a dimension, it's on those things. Of course, nobody watches the videos, but if they did, maybe 10 years from now, that somebody will look at it. Anyway, the Decagon house is a simpler structure. This house here is 33 rooms. The Decagon house has 29. So, and the difference on why this isn't 34, since there's 17 on this first floor, is that wall between the kitchen and the classroom isn't there. That's the workshop. So, and also the stairwell comes up in there, leaves a big hole in the floor. I'm kind of thinking we were talking a circular staircase in this. I know there's a circular staircase in the living room, but it could be that the straight staircase is over here in the living room. Like you have the front door, and then a staircase would go up to the next floor. And then the circular staircase must have been in one of these corners. I kind of think it sits right here in the classroom. We did build a circular staircase in the Decagon house, and there's a monostringer circular. Well, they're not circular; they're helical. A spiral staircase has got a center pipe, and all your treads run to the center pipe. Helical is like a helix on a DNA, and there's a big core in the middle that's not treads. I think it's 26-inch diameter on the one we built. And at the time, we were thinking we might put a brass barber's pole or fireman's pole, and us and then the kids and then any guests that were adventurous could just slide down that 12 feet rather than